20 seconds and counting. Guidance internal. 15, 14, 13, 12, 11, 10, 9. Engines on. 5, 4, 3, 2, launch commit.
Surgeon. Go.
Flying away from the Earth and exploring outer space. This has been our dream for generations. In the 1960s, man entered space successfully, marking the dawn of a new era. At the turn of the 20th century, man invented aeroplanes, which took people off the ground and into the sky. The aeroplane has now become a common means of transportation. But why is it that it wasn't until over 60 years later, in the 1960s, that man could fly beyond the atmosphere and enter into gravity-free space?
The reason is that the rocket must have sufficient propulsion force to free itself from the gravity of the Earth and push itself out of the atmosphere into space. And in order to build a rocket with a strong propulsion system, sophisticated electronics and a delicate engine, we need knowledge and skills in various aspects of science and technology. We all know that after throwing a tennis ball upwards, the ball falls back quickly. This is due to the effect of gravity. Blow a balloon and then release it. We find that the balloon flies freely in the sky until all the air in the balloon is ejected out. Then the balloon falls back onto the ground.
Observe closely and you'll find that the direction of the balloon when flying in the air is opposite to the direction of the ejected air. To force the air out of the balloon exerts a force on the air. This is known as action force. At the same time, the ejected air exerts a force on the balloon equal in magnitude but opposite in direction. This is known as reaction force. It is the reaction force that makes the balloon fly in the sky in the opposite direction.
A water rocket operates on a similar principle. The compressed air in the water rocket acts on water and forces the water out of the rocket. Meanwhile, water has a reaction on the air in the rocket. This propels the water rocket and makes it fly upwards.
The fact that a rocket can free itself from the gravity of the Earth and rise upwards can also be explained by action and reaction. Gas is ejected from the rocket's engine, resulting in a strong action force. A force of the same magnitude but opposite in direction arises at the same time to push the rocket. In space, there are no supplies of air or oxygen. Combustion is impossible with fuel alone. So a rocket must bring with it an oxidizing agent to produce oxygen. The most common oxidizing agent is liquid oxygen. There are two major types of fuel used by rockets, solid fuel and liquid fuel. Rockets using solid fuel are simpler in structure and can create a strong propulsion force. A rocket using solid fuel must be able to withstand pressure more than 10 times that of atmospheric pressure. So, a rocket using solid fuel cannot be used to launch a manned spaceship.
But a rocket using solid fuel can be used as a supplementary propelling rocket to add to the propulsion force required for the launch of a space shuttle.
We have main engine ignition, 3, 2, 1, and solid motor ignition and liftoff. Liftoff of the first operational space shuttle mission with 2 satellites on board, and the shuttle has cleared the tower.
After exhausting their fuel, the 2 propelling rockets using solid fuel detach themselves from the space shuttle and land in the sea with the help of parachutes. They will then be recovered, repaired, and reused.
Kennedy, and we're towed in and are in pretty good shape. So I think this is clear-cut proof that we do, in fact.
The structure of a rocket using liquid fuel is more complicated. The fuel is stored within the rocket and is ready for combustion in the engine. The time of combustion is also longer. This is useful in controlling the propulsion force and speed of movement of the rocket, helping the spaceship enter into and leave its orbit of the Earth. Liquid hydrogen is the most commonly used liquid fuel for rockets. Currently, all manned space expeditions are carried out with rockets using liquid fuel. Liquid hydrogen is an environmentally friendly fuel. Hydrogen can be decomposed from water. After combustion, liquid hydrogen combines with oxygen to turn into water and doesn't pollute the environment.
In the early days, due to restraints in technology, rockets could not be reused. The size of the cabin for carrying people in a rocket, whether large or small, that returned to the Earth in the end was only a small portion, usually less than 20% of the entire rocket.
If we look at the structure of a manned rocket, we can see that most of the rocket is used to store the fuel and oxidizing agent needed to propel the rocket. The remaining portion is the space cabin, control system, and propelling engine.
A rocket is largely different from a jet plane. A jet plane flies only in the atmosphere of the Earth. The structure of a jet engine is entirely different from that of the engine of a rocket. The propelling engine of a jet plane takes in air in front, accelerates it with the jet engine, and jets it out in the back. The principle of action and reaction applies in propelling the plane forward. The propelling engine and fuel of a jet plane occupy only a small portion of the entire plane.
The goal of placing an American in orbit was realized by
A rocket, on the other hand, flies into space. The engine of a rocket has to generate a much greater thrust than that of a jet plane. Also, a rocket has to operate in an environment without air. Therefore, most parts in a rocket are used to carry liquid fuel and an oxidizing agent. The speed of a rocket is different from that of a plane. Therefore, a rocket has to have a unique design. For most of the time, a jet plane flies slower than the speed of sound, but a rocket has to move forward at a speed several times that of sound to free itself from the gravitational pull of the Earth and explore outer space.
The outer design of a jet plane is also different from that of a rocket. A plane flies within the atmosphere of the Earth, so a plane must have a streamlined design to minimize the friction caused by air when moving forward, and to allow the wings to lift the plane. Meanwhile, The engine accelerates the air that it takes in and jets it out at the back to propel the plane forward.
Was launched by a two-stage A1 rocket.
The flying speed of a rocket is even greater. Therefore, a streamlined design is necessary to reduce the air friction when the rocket ascends.
Including Lunik 2-1.
The tops of all rockets are in the shape of a cone, but the designs of the cabins for space explorers inside the rockets differ according to their functions. A rocket with a cabin carrying people has to go through the atmosphere to return to the Earth, so it has to be in a streamlined shape to reduce air friction.
Gemini 8 was ordered to return to the safety of Earth.
But if it's planned to only fly in space where there is virtually no air, it's not necessary to consider air friction.
Rocket cabins and spaceship explorers may have strange shapes as required by their tasks. For example, the space cabin for people that lands on the moon is like a beetle, whereas space explorers targeting other planets may have unusual shapes. There's no need for a streamlined design.
It will orbit Jupiter and release a probe to study its atmosphere. With the exception of Pluto, space probes have visited